So, level editor. Let's see first the features we're going to see. Of course, we will start with choosing the side. The maximum level we're going to have is going to be 256 by 256, and the minimum will be 32 by 32. Okay, it's the same size as a game that shall not be named, but you can guess it's been inspired this from. Okay, so basically the level editor, the features we're going to see is, of course, we're going to have air tiles and regular tiles, which they update automatically depending on their position and depending on their neighbors, as we've seen on the previous video. Non-destructible. Okay, we can paint either regular or non-destructible with the same rules. Okay, in the background, in the backdrop, okay, which is basically non-interactable tiles. They are just there for show. Doesn't matter, I can have regular tiles too. They work the same, they update the same depending on the neighbors. And of course we can have parallax, and I only have 2 at this point, and we have 3 different levels of parallax. Okay, and if I place them there, they update depending on the camera's position. They have an offset, so if they are really close on the first level, the offset is something like 0.2, and if they are back over there, the offset is much further. Checkpoints, where the character is going to start. Of course, if you do this, it's only going to take the very first, or the one that is furthest to the left. If it's like this, then it's going to look, it's going to basically take the last one it finds. Okay, so pretty much this is tile set. I didn't have another tile set, so we're not going to see anything about a tile set. Delete all this. Okay, of course, save and new level. Although new level, as you can see, it will start a new level directly from the start, so it's not going to load the pre-made level. Let's go directly to the scripts, since we have seen a lot of the stuff, and we're going to go directly into the level editor. So the level editor is what controls which style we're actually painting. Okay, we're going to need a few resources. Of course, we're going to need the namespaces, map creator, and resources manager. The active tile set, we've seen the tile set on the previous video on the map creator and how it relates to what we want to do. Paint tiles, backdrop, player start position, basically what exactly we want to paint. Parallax, okay, parallax ID and the parallax level, the tile type we're going to paint, the mouse indicator, camera target, which is what we follow, previous node, the previous node we have painted, player start position, all our level checkpoints, and the checkpoints parent. When we initialize this, we've seen where we do that. It's from the Decision Master. We get the references, and we also load the player start position prefab, which is, it has to be inside the resources folder, of course. On update, if we are over a UI element, we basically do not want to do anything. So how we check if we are over a UI element? We're going to check if the event system, if the current event is pointer over a game object. Okay, so if we want to paint tiles, if it's enabled and not over a UI, basically, we're going to set the active tile set, whatever we have as the index into our resources manager, and we're going to use this function return node from mouse position, so that it returns us which node we are over our mouse. Since there's actually world collisions, so every node has its own collision, then we do not have to do a lot of stuff. We only do array, and that array we get a point. We don't have to do a raycast, okay, because it's basically whatever position I have over here. Oops, not multiplayer. If this position, if the world position is 5 on the X, on the Y, and on the X, then it's going to also be the same node. Okay, and it's because the way we've created, well, basically the way we have set to create the grid. Okay, so the very first one will be at 0, 0, 0. Taking into account, of course, the, as you can see, 0, 0, 0. Taking into account, of course, any offset we might have. Yeah, we have one offset, so it's pretty much the same. So we do not have to do any raycasts. And then we use basically from the map creator get node world position, and the world position is what we get from the array. Let's go back. Okay, we have our node. If our node is null, then we return, just in case the mouse is not over an actual node. And we place the mouse indicator transfer position to be the same as the, the current node or the actual node references on transform dot position. The mouse indicator is the little pink dot you see. Note this, the white ball is the actual camera target, so we can follow, so we can move basically our camera, and it's also clamped to the size of the level. It's also very shiny. Input get mouse button. If we press mouse button and if the previous node is not equals the node we have over here, or the previous node is null, then if we're not painting parallax and we're not painting an active checkpoint, we're going to paint a node, and we're also going to update the neighbors. To paint the node, we pass a node, we pass the current tile type, and backd is what this is. Oops, forgot what this is. If it's the backdrop. Okay, so if we are painting on the backdrop or not. If the type is not equals R, that means we actually paint something. We need to find the texture ID, and we do that by using getID for the current tile type and the node we currently have. If the type is regular, then we do, as you remember, for our IDs, we had a vector 3. The Y was the actual tile. So for example, if it's a regular tile, we want a random value between 0 and how many tiles we have placed into our list of regular tiles inside the tile set. If the X equals 0 on our texture ID and texture ID.z equals 1, then that means it's an edge tile. So we set this to be as, we take it, instead of getting a random tile from our regular tiles, we get a random tile from our edge tiles. Okay, because we use this function when we actually load them up, not only when we create it. And we set the texture ID, the Y, we set it over here. If the tile type is non-destructible, we're going to do the same. Okay, but take it from the non-destructible list. In this example, we only have one, so it's always going to return the same one. Okay, and then we use, we get the sprite from our resources manager. If it's not, we're not painting the backdrop, then we update the sprite renderer for inside the node references, the one we call SR, which is the front one. We update basically the vector 3, the ID for the main texture with what we have as texture ID over here, and we also set the tile type to be the current tile type we type over here. If the node reference is destroyable, we select it by the type. If the tile type is non-destructible, then it's not going to be destroyable. And we set the type to ground the node type, okay, not the tile type. If we are painting the backdrop, we pretty much do the same. Instead, we also enable the backdrop game object. We assign the sprite, we store the texture ID, and we have a backdrop to be the type we have saved. Okay, just so that it's either ground or air. If the tile type we want to paint is actually air, if it's not the backdrop, then the node we have is going to turn it into empty, and it's going to set the tile type to whatever type we have, which in this case is air. If it's the backdrop, we're going to do the same, but we're going to unassign the sprite, and we're going to disable the game object, and we're also going to set again the backdrop type to be air. Else, we're going to see if it's a player start position, if there is a checkpoint on the node we have placed, and if we found a checkpoint, then we're going to remove the checkpoint from inside our list of all our level checkpoints, and we're also going to destroy that game object. Basically, yeah, we basically use the same key to remove checkpoints and remove tiles. Okay, just because I didn't want to have another extra key just for the checkpoints, just for deleting checkpoints. How we see if there is a checkpoint, we have this list, and basically goes and checks into our level checkpoints list. We pass the node, and if it finds a player starting position with the same X and the same Y as the node, then that means that node has a checkpoint. Okay, simple enough. I think it's way easier this way than the previous level editor. Okay, so that is how we actually paint one node. Get ID, where did we use this? Yeah, we use this on the paint node. So the first texture ID we're going to take with type and node. Get ID, we're passing the type and we're also passing the node, and it's going to set it as it's going to do the initial setting. So in this case, it's going to check if the tile type is regular. If this is a check that, looks if it has ground above. If it does, then it's going to return that it's a regular type, so it's not an edge type. Else, if it doesn't have ground above, it's going to return, the return value will be 1, so that means it's an edge tile, but we now need to find if what kind of an edge tile. So we have another check if is left corner and is right corner, and we're going to check if both left air and right air is false, then return value will be 0. That means it's a tile like this. It doesn't have anything around it. Okay. The regular types are these. The edge tiles are these. The ones in the middle, and the corner ones are these. Pretty straightforward. If both of these have air, do not have, although I think with is right corner, return value, yeah. So for instance, it is right corner. We start with the return value to true. Okay, we take it like it's a corner. We check if there is actually a node on the +1 of our X, since we check for the right. And if the right node is not null, we're going to check if it's the actual backdrop or if it's the normal one. Okay. And if it's also ground, if the tile type is ground, and for the front, for the backdrop, we're also going to check if the tile type is air. Okay, then we're going to return it false. Okay, simple enough. If we found the ground, then it's not a corner tile. Yeah, exactly the same with if left. Of course, we could have encapsulated this, but anyway, the only thing changed is this. Instead of +1, we go to -1, and the above one has ground above, exactly the same, only we have the Y on the +1. Okay, you could keep them as it is though, since they have, yeah, if you want to add more behaviors in here or on the ground above, you can just do that. It doesn't matter, since, yeah, it works. So anyway, okay, we were over here, left air, right air. If both of these have air, then return value is going to set to 2, and else, if it's only left air, it's going to set the X as -1. If it's right air, it's going to set the X as 1. So basically, the hard thing is remembering how the ID works. But since you only have to do this once, write it once, you set your own rules. So yeah, it's pretty easy. It's not that hard. If it's not destructible, then the Z is going to be 2. If it's tile type air, then don't do anything. It will return as 0, 0, 0. Okay, that's the get ID. So whenever we paint the node, we were over here, we also update the neighbors, and we need to pass the node so we know what neighbors to update. Update neighbors is over here. We do a for loop, okay, to get all our neighbors on the X, one neighbor on the left, one on the right, and on the Y we do the same, one below and one above. Target node will be, we get the node from our map creator, and we add the 4X and the 4Y. If the target node is null or the target node equals the node we are looking for, then continue, skip this part of the for loop, and you have our node, paint it, paint the target node. If it's backdrop or not, you're either going to assign it as a backdrop type or the tile type, and we also pass if we are painting backdrop or not. Pretty straightforward. I don't think you have any problems with this. If we're not painting parallax, or we're painting a parallax or a checkpoint, we have an else if and an else if. Okay, if it's not a player start position, then that means we're painting a parallax. So what we're going to do, we're going to do another ray, this time screen point array, input position, wall position, we're still going to get the get point +1, and we have a wall position for our parallax. So we basically have an X and Y, and we just set the Z to be further away inside the level, and we call the function paint parallax. Parallax ID is what sprite we're using on our parallax into the current tile set. Parallax level is on what level we're going to place it. We have 3 levels currently. Resource manager is going to be the tile set index, so the index of the tile set. This will always be 0 since we only have 1 at this point, and the wall position we have over here. Paint parallax, we use this function whenever we load the map too. Okay, not only when we create it, similar to paint node. So what we need to do is basically find the sprite, instantiate a parallax prefab. We set it as a parent of the current parallax level. We have objects that we parent below, and instead of moving all the parallax objects together, we just move the parents based on the offset set by the level. We're going to see this in a bit. The target position will be, of course, the local position of the parallax parent. We set the y to 0, so it's also leveled in, and we reset the local position to be the target position, although this will work, although I think let's just keep it like this and we'll see. Sprite renderer, we get the sprite renderer, we assign the sprite, we set it as the sorting order. Notice this, if you are on mobile, you probably do not want a lot of parallax, since the sorting order means that they have to it's going to be packed differently, so this might have more render calls. Just keep in mind of this. Just set it to 1 or just use fewer parallax, I don't know for sure. And we're going to set the sorting order minus the level multiplied by 2 plus 3. We multiply this by 2 because we have gradations between those sorting levels. Okay, so we have with each parallax level we also have a fake gradation, so we have some fake atmospheric effect between the sprites. If this was a 3D game, we're going to use an image effect to create that, but since it's not a 3D game, we have to cheat a little bit. And we're also going to add a parallax object, which is a script that has a few stuff that has to do with the parallax, like the position, the wall position, which is a vector 3, the parallax level, the texture ID, the texture set ID. Okay, just a simple script. And whenever we want to save the level, we're going to use this function, which is going to create a new savable parallax class, which is in the level serialization. We will see this in a bit. It just updates the positions or the values from over here and returns a savable parallax, which in turn we serialize and so on. Okay, we get the parallax object and we store the position, the level, the texture ID and the texture set ID. Very simple. We've seen our paint parallax. Now, if we want to place a checkpoint, we're going to check first if it's a duplicate checkpoint. So what this does is it looks if there is another checkpoint inside our list of checkpoints, and that other checkpoint has the same X and the same Y as the node we want to paint on, it's going to return true. If there is already a checkpoint, then it's going to return without doing anything. If the checkpoint parent is null, it's going to create a new checkpoint parent. It's going to instantiate a player start position prefab. It's going to assign it at the wall position as the node references. Player start position is going to get the component we have on the prefab, which is called player start position. This one, we've seen it. Okay, X, Y, init for game just closes the indicator, which is just a game object with a tick. And it's also on the UI, the indicator is a UI element, I think. Although, yeah, the whole game object, the whole prefab, I think it's a UI element. Or no, it's just a sprite, yeah, just a sprite, so forget what I said. Okay, init for game is going to close the indicator, init for level editor is going to enable the indicator, and savable get position is going to create a new class, savable start position. It's going to update the X and the Y, and it's going to return that new class. Okay, we add it into the list of our level checkpoints, so we can do checks with it later. If we are into the level editor, then it's going to init it for the level editor. Else, it's going to init it for game, which is just simply closing the indicator. Unless you want to have indicators inside, yeah, I think in Broforce they just had those flags. Okay, so if you have something that the players can see that it's a checkpoint, then there is no need to disable the indicator. I just have a tick, so it wouldn't look that good. And then we set it, we parent it under our checkpoints parent. Then checkpoints, close all, clear reference. Of course, it's a singleton. Clear references destroys the checkpoint parent, the active checkpoints, and it clears the list of level checkpoints. Okay, we've seen this on the previous video. It's called by whenever we want to clear the grid inside the map creator. Return checkpoint, it's going to return you the list of checkpoints. Close all, it's going to close the parallax, going to close the start position. It's not going to close, it's going to close what we are actually painting. So parallax false, player start position false, tile type is going to reset it to regular. Okay. And yeah, as much as the level editor is concerned, the structure behind it and how we paint and all that, we are done. Let's see the actual buttons and how they hook on the level editor. So, for instance, we have all these buttons over here. For the most part, they are the same. We have two game objects, and yeah, left upper corner, right upper corner. Okay, left upper corner, we parent everything under a grid, and except the tiles that have tile set that have a slider next to them. Okay, all the others are using the same script. So here we have level editor button, which is a script, and we reuse it with every button. Level editor button, let's see the enum for this. The types of level editor buttons we have: regular, not distractable, backdrop, parallax, air, tile set, and start position. Slider, tick. The tick is this thing that whenever we click it, it opens and goes off. Okay, it's all inside the same thing, the UI elements. You have the starter object, so download it. If you do not have the starter object, it's in the intro video, so you can go and see that. Okay, this is the toggle. Even if we do not use something like we do over here, then it doesn't matter. It's going to either automatically assign it or it won't need it, depending on what you select. When you're pressing a button, we check if we have a button, then it's going to get the component. If the tick is null, it's going to go and search for the toggle for, yeah, it's going to basically assign the references the first time you're going to press that button. Then it's going to go into the level editor button manager, which is a new script, and it's also singleton, and it's going to call the function button pressed, level editor type, tick. And in case we want to, we also have a slider. It's going to come over here, it's going to see if we have an actual slider, and it's going to call on the level editor button manager. It's going to call the slider change value, and it's going to pass the type we have on the button and the actual slider. Okay, so for instance, the parallax hooks with level editor type parallax, and we also have the slider. Okay, and the non-distractable, for example, will hook with level editor type non-distractable. Let's see the level editor button. Level editor button, it's also a singleton, and I think this one goes on the level editor. In one of, you only want to assign the level editor button manager in one of the menus. It doesn't have to be on all the menus. So over here I just assign it on the left upper corner, since this is the bulk of it. Okay, these do not need to have the level editor button manager, since they are kind of special cases. And back to menu has to do with the main menu. It doesn't have to do with the level editor precisely, since we reuse it for all our cases. So, level editor button manager, reference to the level editor, active toggle, the tick. We'll see where we assign this. Slider, tile set slider, the parallax level, the slider for the parallax level, parallax submenu, which is the submenu for the parallax. It's whenever you click parallax, it opens another object over here, which is a grid, and it's going to create. It's already have created two buttons, since I only know I have two parallax objects, trees or the mountain. Okay, we just need to know so that we open it only when we click on the parallax button. Toggles is going to go and find all the children to get every toggle it can find on start. Okay, it's going to set the active toggle as the very first one it finds, and then it's going to close everything else. So basically it's going to start as air delete. Tile set slider, it's going to look into the resources manager, it's going to find the tile set. It's going to assign it whatever you have on the tile set. Parallax level maximum value is going to be 2. So we have 3 parallax levels on the slider in this case. Okay, we have 3 because we start from 0. Tile set slider whole numbers, we're going to set to true. Parallax level whole numbers to true. And parallax submenu set active to false. So we are closing the parallax submenu whenever we start. Button pressed. The level editor type, tick. Parallax submenu set active false. Okay, we close the submenu whenever we press the button. If we do not have a level editor assigned, then we're going to also get the instance. Now, depending on the type we've pressed, we're going to update the values in the level editor. So, first thing we're going to do is close all into the level editor. Notice that we do not have it on all the cases, otherwise I would just have had it over here. Regular, close all, set the tile type to regular, active toggle is on false, so the previous active toggle will be false. We're going to reassign the active toggle with a new one, or with the button we have pressed. Okay, and open the new one. Same with the not distractable, but we're going to set it to not distractable. If it's a backdrop, okay, we do not want to lose if we are painting regular or non distractable. We only want to have to paint it on the backdrop. So it's going to go into the level editor and have the backdrop be the opposite of what we have. And it's going to reassign. It's going to say tick is on level backdrop. Same with the parallax. Level parallax to true is on. Active toggle tick. Parallax submenu. Although you can place on the parallax close all. It wouldn't matter. Air. Close all. Change the tile type to air. False. Tick is on. Start position. Close all. Player start position true. False. Tick. And the new true. And the default has nothing. Okay. So that's what we use when we are pressing a button on the level editor. Slider change. Whenever we change the slider, we need to pass the actual type. So just in case we have set this to wrong and something else that is not parallax, or later on if we have a different tile set, we will add the behavior over here. So we're going to take the level parallax level which we have on the level editor. We're just going to do a mathf round to integer, and we're going to take the value from the slider, and that's pretty much ready to go. Okay, our singleton, and I think we are almost done. And let's see the new buttons, the other buttons. And actually we're going to see the level editor camera target. Okay, inside our level editor, so we can move around, we have this little dot. Okay, editor target inside the level editor. It's just a dot with a sprite, and it has the script which is called level editor camera target. it needs a reference to the map creator because we assigned the position. Yeah, it actually doesn't. Oh yeah, it needs it. We need a reference to the map creator, and on update we're going to update the target position. We're going to get our target position with our own transfer position. Then we get our target position, and basically we want to add on our target position depending on the horizontal and the vertical axis we have from our inputs. Now we want to clamp it to never go outside of our level. So the way we're going to do that, we're going to get the target position X and Y, and before we apply it on our transfer position, we're going to use mathf clamp. The X value is going to be clamped between 0 and whatever we have as maximum X on the map creator. Usually, or probably, you need to take into account map creator, the offset too, but since I know I'm using offset as 1, and I also know that my sprites are based on the size of 1, so that probably makes it so that I'm not ever going to go and change the offset, because then it will break everything. Okay, we will going to keep it like this for now. If you have problems with that, then simply go and change this and add the offset. So this is the camera target. Let's see the actual camera script though, and it's called camera manager, and this is what moves the camera. Now the camera, the rig, is just an empty game object, a shaker. So we have a script that shakes the camera when we need to inside the game, and the main camera with any image effect. Okay, you can see more info on this on the intro video. So camera holder has one script called camera manager. It gets a target, move speed, level editor, and if we are in game. This controls the behavior of the camera. References: if we are references map creator and say camera transform, and camera position some private variables. On start we get the reference for the shake camera. This is the script, we've seen this one already. Position shake range, new vector 3, position shaking, timer, max timer, position, transfer local position. Okay, and we use all this. Smooth random, I think it's a library from the Perlin noise. Yeah. So remind me to paste this link over here, or the script, if I do not have it already in the description. Okay, so that's what the shaking it does with timer.delta time, and when it's over the timer, then it's going to stop shaking and it's going to lerp it back into the starting position. We get the camera transform so that we do not have to write this all the time. The camera position will be set as our own transfer position, and we also get the references from the singleton of the map creator. On fixed update, if we have a target, we run the logic for game camera. Okay, origin will be our own camera transfer position, and the direction is going to be the camera transfers .forward. The ray, we do array to get a world position. Same thing, array get point 25. Since this is 2D, it won't matter how far you are inside over there, but yeah, it's best to not be at the same level as your sprites, otherwise you won't be able to see it. And with this in mind, okay, the camera is here, the sprites are over here, and the camera holder is at the same level as my sprites. Or, well, almost exactly the same. We have an offset basically from the target, and if the target is greater than a threshold inside the camera scene, so you can say I can move freely without moving the camera at this point, but if I pass the middle line of the camera, then the camera starts moving. So the free zone or the safe zone is about this much. Of course, this is intended for left to right gameplay, so all your levels should be starting on the left, or just change it to the opposite if you don't want that. Okay, and also if we are going up, if the target is higher than up, then it's going to move with the camera. Okay, so how we have those limits? We're going to find the origin, which is going to be transform forward direction. We've seen this. We do array. The target position will be whatever the target has. The target we have assigned over here. We need to find the lower edge of the camera. So basically align a point over here. We use a function which we're going to write, get edge, and we have an enum to select what edge we need to find. If we pick definition, we have center, bottom left, bottom right, up left, up, or down. Okay. Center, up, down, bottom left, bottom right, up left. Pretty simple. Get edge. We start with return value of 0, vector3.0. Okay, we need to pass the center. We find these edges mathematically most of the time. To find the vertical, we're going to use the orthographic size of the main camera. To find the horizontal, that will be the vertical multiplied by the screen width subdivided by the screen height, and we find our horizontal. Return value is going to assign it as the center, so if we do not pass anything or we pass the camera at center, it's going to just return what we have on the center. To find the bottom left, what we are doing is we are adding on the center these values. So to find the bottom left, we're going to add -1 multiplied by the our vertical value plus, bottom left is the left, -1 multiplied by the horizontal. Bottom right, up left. Okay, it's just simple math at this point. We add or take to get the position we want. And this is how we find an edge. Okay, this is a singleton. We've seen the camera edge. And we are over here. We find the lower edge, where the lower edge is, and we let the camera position between transform position and target position, and we set it, we move it by time.delta type multiplied by move speed. And we now need to limit the movement of the camera if we are inside the game. So we set the distance, transfer position minus lower edge dot y. Okay, so what we are doing is we find the distance between the difference between our own transfer position and the lower edges y. So what we are going to do now is do a math f clamp on the y on 0.8 plus the distance and whatever we have as the maximum of our own map of the maximum y minus the distance from transfer position minus the lower edge. Same for the x, but for the maximum x, and we basically have this way we clamp the movement of the camera. So as you can see, even if my target is way out of screen over here, the camera doesn't follow him around. Okay, and this works like a charm. And you basically, as I said, you have a safe zone of over this. If you want to make it the other way, you simply replace this, and then we assign it as our own transform position, and we have our own game camera. We call this whenever we want to add shake. Okay, float value timer force shake camera if it's not shaking, or if we force shaking, we shake camera shaking true, position shake speed value, maximum timer, and we basically update the values of the shake camera so that we do not use another singleton for just the shake camera. Okay, there's no need for that. We use this. So this is the camera. Okay, you can see inside the level editor, although I think this doesn't do anything. Yeah, level editor boolean doesn't do anything. You can delete that. Yeah, you can delete that. Let's see the parallax object, the parallax mover. Whenever we create the parallax holders, okay, you can see the parallax. You can see it over here, the parallax. We run by script. We add the parallax mover. We saw this script where we add it on the previous video. Okay, we need a reference to the camera transform, public float offset. The offset will start as 1, but we also assign this on the map creator whenever we create it. Okay, you can see map creator. When we create the holders, we come over here and get set the offset to be I plus 1. I we have on our for loop. The plus 1 because the first one will have the offset of 0, so we do not want that. We need to have at least one offset, and we multiply that by 10. And the position of the Y, we set it over here on this one. So we were parallax mover. On start, we are going to go and find the camera transform, camera manager, basically. Camera position will be camera transform position. The offset, if it's 0, we're going to hardcode it as 0.1, just in case there is a way somehow this turned into 0. Then the camera position X, or the target position in this case, will be minus the camera position X subdivided by the offset. The Y will be whatever Y we have created this to be, and the camera position Z will be 25. As I said, just we need it to be further inside the level, and we're going to assign our transform position to be the camera position. Let's see these two buttons. I think now it's the right time to do. Level editor, camera target, we've seen this. Level editor, new scene. Okay, add this into this button on click. Go to the map creator, get instance, create new grid. If you want to, though, you can say create new load. No, I need to make that public. So let's go to definition. Level editor pre-made level. Let's make this public. Let's go back. Level editor pre-made level. It's probably going to work. Okay, I'm not entirely sure if it's going to work like that. We're going to see. Level editor, make level, paint something, boom. It worked just like a charm. Okay, level editor, new scene. Save, and the input for the save. It doesn't save when you write the name, it doesn't save it now. It's only going to save it when you hit save. So save is level editor save button, and this has to do more with the serialization. And I think because we are at 50 minutes, I'm going to split the serialization as its own part. Okay, input field, public void save button, input field. If it's null, then go find the input field, get component in children. Target name is going to be whatever we have into our input field. It's going to do a check if we haven't assigned anything on our input field. It's going to hardcode it to be level and underscore, and it's going to set level serializer, get instance, save level, and the target name we have over here, and we'll see the level serializer in depth in its own video. So we've covered pretty much everything for the level editor except the level serialization, which has to do with binary files, and we're going to see the level serialization on the next part. Now you know what to do. Like, subscribe. Also, if you support me on Patreon, of course you are helping me and to keep making all these nice videos. And you also get to see new parts, new videos, new series, everything. You're going to be able to see it earlier than anyone else. And there's also another way you can support me, is of course through Gumroad, and everything goes back into making all this cool and nice stuff. Okay, so next part, level serialization, and I'll see you there.